Yes, hello everybody. How you doing? My name is Hector, and today we are going to present, or we are going to have a new session of the Polkadot deep dive sessions, right? That we are running from Delivery Services team. And in this occasion, what we are going to present is the node implementation. Um, I think like the screen is not sharing, maybe, right? The presentation. Good, perfect. We are done. Thank you. So what we are going to basically review today is the node side of Substrate. Okay, and for like basically making it like a little bit more clear about what we are going to do today is like let's go to review the agenda. I believe like for having an understanding of what we are going to do, what we are going to explain, we need to review the architecture of Substrate, right? Then like going into what it is, the folders and files that represents the client. Okay, let's call it client. The libraries which are involved. Let's go into read a little bit the code from the client side of the Substrate node. Then let's go into to do a little like demo where we are going to like create our own inherent, and of course I will explain what is that about. So the reason why we proposed, to have this like deep dive session is because most of the time, as a substrate engineer, most of the interactions happen on the runtime side. Okay. And by like runtime development, I mean like you get your palettes, right? Or you get your runtime and you start configuring your, let's say, business logic, right? Or the logic for your chain. And basically by doing that, you develop your own palette. Okay. You manipulate like storage items and you create your extrinsics, and basically, yeah, that's most of the times the software developer is working on the runtime side. Okay. But the beauty of Substrate is like there are a lot of things happening behind the scenes. Like you as a Substrate developer, most of the time you don't have to worry about. Okay, like for example, all the consensus part or the networking layer or the transaction pool, right? All those things, like if you have to basically develop your own blockchain from scratch, it's super, demanding and hard to do that. Okay, but anyway, Substrate is so flexible, like allows you to also change the behaviors, parameters, and even the consensus, right, from the client side. So I think like it's important before we dive into the aspects of the client side to like remember or like going through the software architecture in general, like the big picture. Okay, so you have like the Substrate node. When you basically download the Substrate node, what you have is a set of components, right? You have a database, a key value database, which is basically where all the state from the blockchain, okay, is stored. And then you have like all the consensus part, the transaction pool, okay, and then you have like the block builder and the import queue. These are going to be important because we are going to review those in the code, okay? And as you can see, we have different colors, right, for representing to which module belongs to. So in this case, Substrate is of course the whole package, right? Is the node. And the violet, what is in violet is basically the client side, and that's where we are going to focus today. And of course in pink, right, you have the wasm runtime. Okay, and there are interesting things to discuss here. The wasm runtime, okay, basically lives in the database, and that's super powerful because for example, when you do a runtime upgrade, what you are doing is like pushing to the database a new version of the wasm runtime. The wasm blob is stored on the database. And from the runtime, if you wanted to interact with the client, you basically, from the runtime, you access to the node, to the client services through host functions, right? And then the client, or let's say the exterior of the runtime, can access to the runtime values through runtime APIs, okay? And okay, also we need to think what is the process when a block, for example, is created, right? You have basically a block author, like graphs all the transactions that are in the transaction pool, run the the string six, it runs the block, okay, all the string six in the block, validate that everything is okay, and basically the block which is authoring the block, basically, which is the one that is building, distributes the block to other nodes, and basically that nodes import a block, run everything again, and basically says, okay, I have the same state, and that's how like basically the consensus works. Okay, so having this introduction done already, I would like to talk a little bit about the directories. Okay, so if you download your Substrate node template, you will have quite a few folders, but the most important ones are the runtime and the node. In the node is everything that relates to the client side. So all the components which are like in this case in violet, in simplifying it in a way. So okay, if we need to get into that like folder, okay, the node folder, there are a couple of pre-existing files, which are the files that performs everything that was described before. So we have the service file, the command, the chain spec, benchmarking, RPC. Okay, and then there are some others which, yeah, they are, let's say, the leaf.rs, where like modules are exported, like most like related to the Rust modules, let's say. So let's start like for the most. I don't know if it is correct to say the most important, but in my opinion, what it consists the node. I mean, what it relays, the node. There are two files that for me are keys or more relevant, right? The first one is this service file. Okay, the service.rs file is a super important file that plays the role of a service factory. Okay, it's basically configuring and initializing the consensus, the RPC server, the transaction pool, off-chain workers, and basically what it's doing is spawning all the threads, because like the node, okay, the client works with multi-threads, and each like worker thread, what it's doing is basically launching each part of the components. All right, so another one which is important, as I said, is the command file. Okay, in this command file, I don't know, for example, if you have executed the node, you execute the client, so the binary that results from the compilation. Basically, when you provide a parameter, those parameters are basically mapped in this file, the command.rs file. And for example, when you provide the chain, okay, and you said like which chain you want to run, okay, that is of course supported in your like in your node, basically the command file is going to process that and point to the corresponding chain spec. So here, for example, you can see like, here you can see that the command file, has a function which is called load spec, where it's like grabbing the value that is providing on the chain parameter, and it's basically reading the chain spec and, throwing like or retrieving all the values that are configured on chain spec to start your runtime, the specific runtime that you want to run with the initialized values like you need as well. So another important thing on the command.rs file is that invokes the service new full. Okay, so in the Substrate node template, you have this function, which basically is like starting all the services for a full node. Okay, depending like where you're running this from, this function must be called different because there are two different, setups for these service files and these commands files, which is the Substrate node template, which we consider it a solo chain, and then like the service file and the command files, I mean the node folder, which corresponds to the relay chain of Polkadot or Kusama, or the collators, or the let's speak properly, the cumulus node, which is of course the binary that is used to run your collators on the Parachain side. So we will see, I mean, we will basically read code from a Substrate node template, okay, which is like very clear and minimal, and then we are going to see the difference, how like this file looks on the Parachain side, because it has like more complexity, and also there are some considerations which I would like to share with you. So if you remember when I said, like, for example, you are using the chain parameter on the binary, right? When you execute the binary, and I told you that the command file basically gets that value and basically points to which, like, a specific runtime you want to call, and as well like which values you wanted to initialize your runtime. Well, all those definitions happens on the chain specs file. Okay, and for example, you might want to have a different values if you start like a dev chain or a local chain, or of course you want to have like the production values when you want to really start your network. Okay, let's suppose like you get the slot in Kusama and you want to have the real values up there. So all those definitions happen on the chain specs file. And here, for example, you got the example, right? This is like the chain spec for the local version of Trappist, which is a parachain. Like it's a test, it's a showcase parachain. Like we work in the delivery services team at Parity for showing, advanced cross-chain use cases. There are several presentations also here sharing in YouTube where you can like go and take a look about what Trappist is. But we are going to use this one to basically show the code and to also present from the Parachain side how it looks like. So in this case, very simple. You define like what is the token symbol, like the native one. In this case, it's hoop, the token in decimals, the SSH 58 format for the addresses. You define like your Genesis block values. You define it in here in the chain spec file. Then there is this one, which is the benchmarking.rs file. This is super important. And I saw some implementations of nodes not having this benchmarking file. And basically, this is used for measuring the block and extrinsic base weights. Okay, so when you run your benchmarks, on your node, so let's, again, you have also a deep dive session about what are weights and what are benchmarks. But for doing a quick review, for calculating the weights of your calls, you need to run the benchmarking. Okay, but those benchmarks and every extrinsic that you call on your node contains a base weight. Okay, like saying, okay, maybe your interaction is super minimal, right? You don't like do a super big state change, as for example remarks. Okay, but that remark should have at least a base weight, because you are like executing something on the chain and you are consuming resources from your chain. So that's the reason why you need to have like a extrinsic base weight. And basically, system remarks is a very good extrinsic to perform this benchmark for the extrinsic base weights, because it's so light that it can be used for like the minimum, let's say, computational resource and proof size like is needed to calculate your base weights. Okay, and that like benchmarking is defined in here. Then there is another file super important where, like, for example, in the previous learnings deep dive sessions, it was like review in depth. I recommend you to go on that one, which is the RPC. Okay, on the RPC file, you can define all your, first of all the collection of no specific RPC methods like comes already with a node by default. But also in here, you can like add your custom RPCs. I will not go in depth with this like customization of RPCs because the previous deep dive sessions goes very much in depth on that. Well, something interesting is like, for example, if you want to run an Ethereum-like chain, all your RPC methods, like for example, allows like a specific Ethereum wallet, to connect to the node, to the certain, is expecting certain RPC nodes. Well, those are defined in here or initialized in the RPCs.rs file. So this, a little bit, the content for the RPC looks like this. You have like a create full function that is going to be called on the service file, because remember, like we were talking about, that the service file is the service factory for your client or node. Okay, so you will see in the code that this function is being called for, spawning the worker thread for the RPC server that is included on the node side. So yeah, just the second part of the file. For example, in here, I'm showing like this module, you can like basically initialize the create ETH, right? Which is like initializing the RPC, or is basically adding all the RPC specs from Ethereum specifically into this RPC module, okay? All right. So I would like to speak a little bit about the Substrate libraries, okay? And this is an important, as well as an important, like, information to keep in mind when you want to review this code, okay? Because you can like very much separate it in three, categories. You have the you will see like SC underscore something RS. Those relates to the Substrate core, libraries, like for example, SC underscore consensus. Then you have the SP, which relates to primitives. Okay, so all the primitives that are related to Substrate goes on that like directory, and under like that terminology, which is SP underscore something.rs, and the rest, which are like the ones that you probably are most aware. That is the palette and the frame underscore something. Like for example, this one, the first one, an example is the frame underscore system.rs, which is the system palette for frame, or like for example, palette underscore assets, right, which is the palette assets that you configure in your runtime. From the Substrate documentation, I got this, which I think is pretty nice, and it's also pretty much explanatory about how these libraries are like, interacting, and what are like the responsibilities from each set of libraries, right? So you might want to think the core libraries as like, for example, those components like communicate with other nodes. In the case of RPC or like transaction pool, as well is of course this like core interacts with the runtime in a way, or all the node side like interacts with the runtime, are also used here. Not mostly from the runtime, you will see this core libraries, but yeah, it's basically serve these two purposes. And then you have the primitives, which is basically making like the glue, between like the core libraries and the more runtime related libraries, let's say. Okay, so basically they communicate each other through like these primitives, and also then you have like the frame and palette libraries, which very much interacts with the runtime, like the palette assets or the frame support, the frame executive, which is like a super important palette that basically orchestrates all the block production, running the extrinsics in order, and so. So let's go into do a little bit of code walkthrough. All right. So we have like this Substrate node template. Okay. And as I told you, basically you have like a different, folders. But as I promised, those are the two most important ones. Okay, the node and the runtime. So in this case, I will expand the node, okay, one, which is the one that is interesting for us. And we will see here, like you have different, the files that we were talking about. So in this case, what I would like to do is go a little bit through like the service file, okay, which is this service factory for our node. So first of all, I don't know for how long this is going to stay, but right now the node contains two versions of the runtime. You have the native runtime and you have the wasm runtime, okay? And there is this executor with basically decides which runtime to use, okay? And I say, I don't know for how long this is going to stay, because the plan is that nodes, the Substrate nodes, only run wasm, wasm runtimes. So, but for this point in time where like this is happening, where this deep dive session is happening, we have this executor, which basically decides, which runtimes to run. And for example, you have this function, which is like, selecting the native version or dispatching the APIs for these runtimes. All right. And then you basically, through the core libraries, like we were talking about, you have, for example, this Substrate core service library that is defining the type for the full client, okay, the full backend, and the select chain. This one is kind of interesting because it's through the core consensus library, providing all the implementations for selecting the longest chain, okay? Remember, this is a little bit complex, but remember, like you could have like forks in your chain, and you might want to build, your next block on top of the longest chain, all right? So if you start like reading the different functions on the service file, I mean, I wanted to start presenting, the service file from the Substrate node template, because it's very concise, okay, and it's simpler to understand, because there are a lot of things like are reused here on the service file from the Cumulus client, okay? So we will start from here. And basically you have two functions, which is the new partial and new full, okay? Remember, like what we want to do here is like start a full node, all right? But sometimes you don't need like the whole services of a full node, to I don't know, run certain operations. For example, when the new partial is used, when you want to run your benchmarking, you don't want to have like, I don't know, all the, networking layers started, because you just need to use some specific, task for running your benchmark. So new partial is like getting the minimum accepted functionalities for the node, okay, for certain like operations. And then the new full, of course, will call the new partial, right? Because this is code abstraction, it can be reused. And the new full will start the full node with some of the values configured here. So let's go through a little bit this file here. You could see like is defining a default import queue, right? Like basically this is the queue of blocks to import. The pool, which is the transaction pool. Remember, like if you want to execute a call or extrinsic to your node, basically what let's say the RPC nodes are doing is like grabbing that transaction and putting it on the transaction pool. Okay, and then of course when it's the proper time, those transactions that lives in the transaction pools are processed and are verified if they are like valid or not to be included in the block. So then this is important and is kind of very deep, which is the block import. Okay, remember in Substrate you have two mechanisms, right, to your block production and finalization, right? There are certain blockchains like produce the block and finality happens on the same consensus mechanism. In blockchain, in Substrate, you have those split, right? You have your first part of the consensus, which is the block, producer or the block authoring, and then you have the finalization, right? So in this case, the Substrate node template comes with an Aura block authoring mechanism or consensus, which is a round robin, it's a super simple one, and of course Grandpa, which is the finalization gadget. Okay, and this is like a little bit confusing because it's using the Grandpa block import from Grandpa, but from the core library Grandpa. But in reality, this is like a grabber, to the client, to like a default, block import, we will see that after, so it's more clear. And also, of course, telemetry, and this is optional. You might want to start or not a telemetry service on your node. So I will not explain, each part of this file, but for example, you can see here like telemetry is being the telemetry, is starting to become configured. Then you have the executor. Remember what I told you, like, for example, if, the runtime is a native one or a WASM, it's basically, is processed here. Remember, like, the plan is to only have a WASM runtime, so this might change very soon. And then this is interesting, like, is like grabbing the core service, library, and it's calling the new full part. And this is basically retrieving the client, which is the one that is going to be used, like, for example, define the block import, okay, that is going to be used. So, for example, this block import from Grandpa, this client is going to be provided to that, like, implementation. So the longest chain, which is what we talked about, the transaction pool. Well, you can see here, I mean, that through the consensus Grandpa, we call the block import and we provide this client, okay? And this is how, the Grandpa block import grabs, the default client, which is defined here, okay? And it starts like configuring, it starts like adding, all the features for the block import that Grandpa will need to use to finalize the blocks, right? So a slot duration, then this is super important. This is the import queue. And this is like how in this section is how the blocks, are going to be imported. So the block authoring, consensus can basically start producing the blocks on top of the longest ones, right? And they're like, we are going to, at the end of this presentation, we are going to show like, something called adherence, like are like values that can be execute. They are like processes that can be executed from the node, and those values can be used for like for example the consensus. All right. So in this import queue, you will see like there are certain things like are configure. In this case, is the block import, the client, and the inherent data providers, which are like the providers for these inherent, right? These like processes that you can run on your server, right, or whatever, and you can like basically put, provide those values to your runtime, mix it with the consensus, or use it whatever you want to. This is for the ones that likes like concurrency or multi-threading programming. This service file works with something which is called task manager, which basically handles the spawn of all the threads, the worker threads for the service file. And then we just like in here, we return the partial components structure, which represents the minimum. This is like the minimum you need to have to start in a node. Okay. And finally, the new full function, what it's doing is like, for example, starting the network parameters here. It builds the network layer, it, for example, starts the off-chain workers, defines which is the role, if it is an authoring role or not. For example, you might want to run a full node without like authoring, role, meaning like you just like receive transactions and you can put it on the transaction pool, and then that is basically broadcasted to the whole network. Or you can be an author, which is like, for example, being a validator. Okay. Well, you remember like I mentioned, like in the RPC file, you have this create full where you define your RPC calls, and here you can like extend your RPC. Well, on the service file, this section is the one that start the service for the RPC. Okay, and you could see like the create full is called here. Some RPC handlers, and this is the part where I said, like, if this node is an authoring, it's an authority, it's an author role, it contains, the role for authoring blocks, you will basically start, all the services related to consensus. Like, for example, if you are, if your blockchain is, or your chain is an Aura base, here, of course, you start all the parameters for all the Aura, consensus. And you, for example, in here as well, you define your inherence data providers, the block import, the slot duration. Okay, this is like kind of needed to, measure when you have to, select your next author, and yeah, different other values. I need to say that, of course, I'm not like, I don't know 100% of each line and each configuration that is happening on this file, because, of course, it's not like trivial to know all this. But I think like it's super healthy, and at some point you might need to know this information. Like, for example, you get your node template, your Substrate node template, and you wanted to add staking, or you wanted to change Aura by Bave. Exactly in here is where all these changes has to be done. Okay, you are enabling Grandpa, of course, because if this is an authoring role, an authoring node, this will have to get the gadget for finalizing the blocks, and so. Then, if we are going to the command file, which is for me the other most relevant files beside the service file, what is happening here is like you can see like different, commands that can be run. Like, for example, when you, on your node, you run the build spec for creating your chain spec file, this is like the section of this command.rs that's process, like that request. Or for example, you want to export the states or export block, import blocks, or benchmarking, right? For example, you wanted to, when you run the benchmarking for you want to basically run the benchmarking from your palette. This is the section, and this is like all the code, that is executed. So you might maybe you have a question, right? Like you say, how, like, I don't know, when I run my benchmarking, how, my overhead, which is like this these base, extrinsic ways are calculated, where and how it's run. Well, you can come to this section and see what is going on, and for example, another thing that this command file contains is the try runtime. Okay, so the try runtime is this tool like allows you to test your runtime upgrades and your storage migrations. Well, these services are spawned here. And in case like this is not a try runtime command, or it's not like a benchmarking, what is happening is like in here all the services, the full node services are started. And if you remember the slides, service new full is the function that starts, that basically calls the partial, the new partial, it starts like the minimum required, and then starts the networking layer and spawn through these worker threads, all the services that you need for your node. Something I would like to show you as well. Let me see if I can find it. An example. Yes. If you remember, like I told you, like, for example, for build spec, where is benchmark? Okay, let me see if I can get one here. Yes. So, for example, for benchmarking, I told you that you don't need the full version of the node, right? Just with the minimum services is enough. So if you check it here, like this section of the benchmarking is like calling the new partial, right? Because benchmark does not need the whole full node services. So here you can see how this abstraction is like reducing, the load when you run benchmarking. Okay, so I wanted to show you something. I told you like this on the node template is the most simple implementation of these files. And now I would like to show you the equivalent of how it looks like on a real like production parachain. Okay, remember that Trappist is not like a production parachain, but tries to be, to emulate a production parachain. And the last month we were trying to, deploy, and actually we deployed Trappist in Rococo. And we went through a very interesting process, which was like, okay, what it requires to get your parachain template becoming, that parachain template becomes like a local testing parachain, and how you turn it into, a more production like parachain. So the first thing we needed to do was to review like all these files from the node. And here there are some complexities like maybe you will need to take care. Most of the time, a parachain, a real like a parachain project does not contain only one runtime. It has like several runtimes. Let's suppose like you want to have a runtime for Kusama and you want to have another runtime for Polkadot, but of course you don't want to have it two separate, you don't want to have it two separate nodes or collectors. Okay, you just want to have only one collector which is able to process different runtimes. That's another super, powerful feature of Substrate, right? You could run whatever runtime you want to, and if it's compatible, of course, but with one node, you can process different runtimes, right? Because they are two separate things. As soon as your runtime is compatible with the node, and it matches like all the host functions and the runtime APIs, they match, you can have like more than one runtime in your project. So another thing which might worth mentioning is like a Parachain node contains also a full node for the relay chain. Okay. And you will see that as well. That's a difference from the Substrate node template. Again, I know like the plan is to separate this, basically that part that where the Parachain client needs to be aware about like the what is happening on the relay chain through these full nodes of the Parachains. There is like a way where all that communication happens through RPCs, right? From nodes running on the same server, for example. But I think that is still ongoing. I might be wrong, but in this setup, at least, it's like spawning like the two nodes, right, as part of this service file. And another thing, like is might be interesting as well to mention is like we have two runtimes in Trappist project. One is the Trappist, runtime, and the other one is the Stout, right? There are two different runtimes which are used to, I don't know, testing, cross-chain interaction between two parachains, or using the asset hub, as a reserve. So we need to have two runtimes, okay? And you might see, like, for example, related to this executor, like basically picks like if you want to use your WASM or your native runtime. We have two implementations. One is for Trappist and the other one is for Stout. And this one we are using, or we are relying on Rust build features because, for example, there are times where you just want to compile, one runtime only. So, for example, we don't have a Stout deploy, on Rococo yet. So what's the point of building, the Stout runtime, right? So we just need the Trappist runtime. Or like for running benchmarking, we don't run benchmarking for Stout, right? So we only do it for Trappist. So by like using these Rust build features, we could like pick which ones we want or which one is the default. In this case, is Trappist, okay? But there is something that I would like to show you, right? And let's like compare it. Sorry. Okay. So if we go to the service file and we go to the definition of the new partial, this is the whole firm of the of the function. Okay. So basically, you have only a config file, a config parameter, and then just the result type, and that's it. But if you come to the Trappist one, you will see like, okay, you have the import queue, okay, which is different. I mean, it's another one, it's an additional one. And then in this where statement, you all have a lot of trade bounds, okay? And the reason why we need to have this is because each runtime contains its own runtime API definitions, right? So you could have like, they are different, might have like different implementations for your runtimes. So this is the reason why you need to define them. So when you start these functions, knows like that you will provide certain like types that are part of your runtime, but they might have like different behaviors, but with the same like trade bounds definitions. And for example, there are like some also differences in this file. So you have the new partial, which is very much similar to the one like we used before, we saw before in the Node 10 template. Then you have this start node impl that if you start like reading it, of course, it's calling the new partial. Okay, it's like basically getting like those like minimum needed requirements for start your node, and builds the relay chain interface. Okay, build the network, spawn the task in here. Like basically, this is like spawning, the worker thread for each, functionality of the node. But there are like different functionalities in here that they are not in the Substrate node template because this is a Parachain client. Okay, so here you have the start collator, right? If this is an authority, this is wrong. This is not validator. This is actually this should be called collator. So basically, if this is an authoring node from the Parachain side, which is a collator, basically you would like start the collator services, or if not the case, you start a full node. Okay. After all, what you do is you start a network. Okay. There are some like other like implementations that are defined here. Produce candidate. This is super related, to the Parachain side because it's the POV. Okay. And there is and this start Aura node. This is a Parachain based on Aura. What it's basically doing is a grabber of the start node impl. All right. So you have like the Parachain config, the Polkadot config, which is the relay chain full node. You build the Aura consensus through the build Aura consensus parameters. These are like pretty much the similar to what we have in the node template, but if you check the inherents here are completely different because you don't have only the timestamp, right, as you have in the Substrate node template, where actually it's not the only one that is on the Substrate node template. The inherents that you have there is the slot and the timestamp, and this is the one that is related to the demo. All right. So if we go back to this Parachain, you have like, for example, a Parachain inherent that is provided by Cumulus primitives. Okay. Then the timestamp slot is pretty much the same, and you have another Parachain inherent on here. Well, actually, no, it's not a different one. It's the same one. So you return these three inherents because this is a Parachain node. You have then, relay chain, consensus stuff. You have a specific Aura build import queue. And for example, you see here all the generics because remember, like if you have more than one runtime, you will need to have all the straight bounds. And very quick, if we go to the command file, you will see like you have the same logic. Okay, this command file is processing like if the command is, I don't know, for benchmarking, for trying runtime, and if it's not the case, is spawning the service files for this node on the Parachain side. Is in here, the none. Okay. Well, grabs the chain spec, gets the par ID, the Polkadot client for the full node of the Parachain, and yeah, basically it's starting all your in here. It's calling the start Aura node from the Parachain. This happens on the command file. Okay, so for closing a little bit this presentation, just to give you like a flavor of how all these components interact with your runtime, or how maybe you would like to modify it and build your own consensus. For example, there one example which is on the docs, for Substrate docs, where you can build a Substrate proof of work, consensus. So the authoring of the block producer is based on proof of work. And if you want to do that, you change exactly everything, like, the part of the code where you will need to change it is on the service file, and probably the command file where we were reviewing the code. Mostly on the service file is where you will do all your changes. So the demo I wanted to show right now is like how, for example, if you want to create your own inherent. So remember, like, an inherent extrinsic is a type of extrinsic that is added to each block, and that information comes from the node, from the client, and is basically put in the block and processed on the runtime. Okay, are mainly used to process data from the block producer to the runtime. Okay. In some cases, which is most of the cases, these results from these inherents are like used or has a purpose from consensus. Like, for example, the timestamp is used for the slot allocation or something we will read in the code. So one example is the timestamp inherent, right? So basically it gets the time for the node, when it's building the authoring the block. Basically that timestamp is called from the client and is provided to the runtime, and the runtime plugs it in the block as an inherent. Okay. Something which I think worth mentioning is like, how is the process, how the inherents are read by the runtime. So remember, like we said, like when you want to access to the runtime features, which resides in a WASM file, you do that by runtime APIs. Okay, so basically this inherent, what it will do is like the node executes, the process of this inherent, which might be, for example, having the current timestamp for the server, and basically through runtime's API, it will publish that into the runtime, and the runtime will, process this and maybe can use it for something related to the consensus, or maybe not. So something important is that the inherent should be executed at the beginning of the block, okay, before regular extrinsics. And this is mostly done, on the executive palette, on the frame executive palette. This is like automatic. It's not like you should, go and make sure that this happens. But something which is important is like there should be super light and there should be non-blocking operations. So I don't recommend you to create an HTTP request, as part of this inherence, because that could basically exhaust the whole block limit, that you will have for producing your block. So let's go into add a custom inherent to our node, okay? And where is the code? Yeah, here. So coming back to our Substrate node template, what I did was basically I wanted to create an inherent that reads a value from from the OS, from the server, from the operating system, gets that value and publish it into the runtime into a palette. Okay. It does not very much like shows like a real example of how you use inherence, but it gives you the flavor of the processes. So something I did in order to replicate this process is I created a primitive for an operating system reader, and basically this operation reader is just doing a cut of an OS value, file .txt. And then what you have is an inherent data provider type, which is like the type that expects the node. And basically, you define your methods from these impulse inherent data providers. And you will see that in this function, which is from current OS value, I'm calling the OS reader current value, okay, which is basically this operating system command. All right. I expect that this is going to read the content for this OS value and is going to publish it in here. So my service file pick it up and provide it here into the runtime. Okay. So if we review a little bit the runtime code, we have the runtime APIs, which is what I talked about before. And you have, on the block builder, on the primitive block builder, you have these two methods, which is the inherent extrinsics, which basically calls and, creates these inherents as extrinsics. And there is another one that checks if the inherent is correct or not. Okay. So the way to basically execute these functions is by creating a palette, which I build a custom palette for this purpose. And you have this extrinsic. This is a sign one. Sorry, no, this is not a sign. It's an extrinsic, it's an inherent extrinsic. And basically, with the ensure none, you basically make sure that it's not like a sign extrinsic. Okay. So this one is super simple. Grabs the, the value, which is the content from the file, and puts that value into this storage item, OS value. Okay. Then in the palette, you have a macro, which is called palette inherent. And remember, like, if we go back to the runtime, we have these two functions, inherent extrinsics and check inherents, right? And these two, basically, we are like implementing the provide inherent from the palette. We add this macro and define these two. And here are the implementations and the behaviors that will be executed here for our own extrinsic, our own inherent. This is just like reading the data, super simple. Basically, it's like checking that is correctly encoded and, or there is data. Okay. At this point in time, the runtime doesn't know what, those values are about. It's just for the runtime just read bytes. It's the responsibility from the runtime to give, like meaning to that values. Okay. So the service file is just picking the inherent, throwing the raw value into the runtime pick it up with all this, and just then you give it like a meaning to that raw value. Okay, so remember, like we were talking about the import queue, which is like importing the block. There is like these inherent data providers. Okay, so basically in this part is where you will call that primitive that I defined before with the inherent data provider struct. And finally, you call in here the from current OS value. And after all, you provide all the inherent through, this closure. Then it's like all the magic of Substrate, like calls that runtime API through these macros I basically shown you before. And if we start a network, you might see, like, if we go back to the palette, you will see like every time there is a new block, this inherent is execute and it's calling this function and it's depositing an event. And of course, as the value is always the same in this case, because it's just like a regular file with one value, what we have here is value 1. But this is the text, like the file which I'm reading from my server, and I will say value 2 deep dive session, right? And I will save it. So let's wait until the next block is authored. This is the case. And we see the value now, which is provided from the inherent, is the value to deep dive session, which is the value that was updated from the file. This, of course, can replicate a more like real, example that you might need for your consensus. Take into account that this needs to be a non-blocking operation or like, so you don't like exceed your block limits. But the idea, or why I wanted to show you this, is to see like how the nodes interacts with the runtime, and of course how all the services and what are all the files involved in this client when you need to configure your own network, or you need to go a little bit beyond of what is received on the templates. Okay, so basically that, let me go here again. And yeah, basically that's all. I don't know if there is any questions. I'm not on the Twitch streaming. Okay, so there are no questions. They are telling me here. So thank you very much for joining. Here is, of course, if you want to get involved, you have like the Discord channel or the Ambassador program, which I recommend you to review if you're interested on contributing to the ecosystem. And these are like the different methods for learn and stay updated. So this is pretty much for all. I thought like this was useful for you, and I see you in the next one.